Oh, hey everyone. So I know I'm not there, and I know Ms. Gomez is not going to show up till next week. So I'm just going to give you a little short lesson to for your homework, for your class assignment rather, so you'll be able to do it. Okay. Now, what you're going to need is you're going to need this periodic table, which is located in your blue fusion books. All right. This one is special because they're color coded based off what these elements are. Okay, all the blue ones are your metal elements, they're metals, and the purple ones here, they're your non-metals, and these oranges, these are your metalloids. Okay, now they share properties between metals and non-metals. Now real quick, your metals, these guys are shiny, they're malleable, which means that you could bend them and fold them and melt them, and they could still, like, come back together, and they can conduct electricity and heat very, very well. Now, nonmetals, on the other hand, they do the exact opposite. You can't really bend and shape them. These guys break easily. Okay, for example, think of carbon. All right, that's charcoal. You can't bend carbon; it'll just crumble in your hands. All right, and if you try heating up, it's gonna be set in fire. It's gonna be set on fire. Okay, so they're different. Now, as for the metalloids, these guys have properties of both these metals and non-metals. Okay, so they have their special applications. Okay, so what you're gonna need to know today is how to identify on a periodic table, whether it's color coded or whether it's in black and white, which elements are metals and non-metals and metalloids. Okay. Um, Also, for this assignment, you're gonna be asked, all right, to know the difference between what is an atomic number, what is the atomic mass, and what is the chemical symbol. Okay, now let's look at an example. Let's look at an example here. Let's look at potassium here. Okay, all right, potassium. We know that its atomic number is 19 right there. We know that its chemical symbol is the letter K. We know that its atomic mass is 39.10. Now, what I want you to notice, recognize in the periodic table in regarding to the periods, all right, we're going to be talking about the periods, okay, the ones that go from left to right. The periods, several things. First of all, each period will tell you, of course, the energy shell that the atom has. All right. So, for example, hydrogen only has one energy shell. Lithium two has sodium and so on has three, four, five, six, and all of these elements in this row have seven energy shells. Okay. So that's the first thing we know about the rows, the periods. Okay. But let's look at some other things. Okay. In the period, if I look at the atomic number, it's 19 for potassium. Now, if I go to the right, I see that the atomic number has increased by 1 to become calcium, okay? Just that one extra proton completely changed the properties of that element, okay? If I were to add one more proton to calcium, it would become a scandium, okay? Now, by the way, this is very important, so listen. The atomic numbers tell you the amount of protons there are, okay? And the mass, this is important, the mass of the proton is 1 AMU, okay? That's just how much stuff is inside of the proton, okay? Now let's look at the atomic mass, okay? Now, a good example would be yttrium and zirconium here, okay? Now, yttrium right there, the Y right there, has an atomic mass of 39, and then you add one more proton, and you get zirconium, which has an atomic number of 40. Okay. If you look at the atomic mass of yttrium, we see that it's 88.91, and then when it becomes zirconium, we see that atomic mass is 91.22. Okay, so we know that a proton weighs only 1 AMU. All right, so why is it that when it goes from yttrium to zirconium, it increases by 3 AMU? Okay, see the atomic mass, these are also measured in AMU, all right? And didn't increase by 1, it increased by 3. It went from 88 to 91, okay? So that's an atomic mass of 3 AMUs. And we know that one of them was from the proton. Therefore, 2 of those AMUs came from the neutron, all right? So even though the atomic number is increasing one at a time from left to right, all right, the atomic mass, all right, is kind of jumping as we go from left to right, all right? It goes 39.10, 40 point something, then 44, that's a big jump, and so on and so on and so on, all right? So the atomic mass increases by variable amounts. The atomic number increases one at a time, okay?